It's time to allow our projectiles to intersect with the enemies. So we do that when we're cycling through each of the projectiles. Before we take that projectile and display it, we want to find out after we've updated its position, did it intersect or run into one of the enemies? So we do that by using a for loop. So we have a for loop inside of a for loop. So this time we'll use for int j is equal to 0. J is less than enemies dot length, and then j plus plus to iterate through it. So what we're doing is for each projectile, we're going to compare it against each one of our, this should be a 0, not a minus, each enemy. So we're going to do a comparison of 1 to 1, one projectile to one enemy. So we'll take the first projectile and run through all of the enemies. Then we will repeat that with the next one and the next one and the next one. So we're going to be comparing each projectile to each enemy. So as we cycle through the loop within a loop, we're going through each enemy one at a time. So we did the first projectile, and now we're going to take the second projectile. Now the projectiles, we're using I and then J, so it would be for each I, then we go through each J. So we're looping through, and as we do this, we are finding for each one in each array, we are now comparing to find out if there is indeed any intersection between these objects. So as I've hit now the fifth projectile, I have the fifth unicorn that I am bringing into it. What we need to do is figure out how to intersect these. Currently we have rectangle intersect for player and enemies. We also now want to have a version of intersect that will be for a projectile and an enemy. So if I go into my intersects down here at the bottom, I'm going to take the code that's there, copy it, paste it in, not 3 times. Let's see, try one more time, paste. All right, so we have 2 copies. So one is for player and enemy, and then we're going to make a second version for projectile and enemy. So this intersect we pass in projectile and enemy, this one we pass in player and enemy. Because processing is a typed language, any parameters that we send to a function or method must also be strongly typed. Now we could have sprite as something or another. So if we had more of a inheritance and then we did typecasting, we'd cast something as something else, I mean, we could get away with one function, but it's easier just to have the 2. We just pass in a separate value. So let's go back up here. So now we're back inside the loop inside a loop. It's kind of our little inception thing here. So we're doing a 1-to-1 comparison. We take the first projectile and compare it to each enemy, and if rectangle intersect, and this time we'll pass in the projectile, and the projectile we're passing in is at position I, and then we'll pass in our enemies at position K. So now we are passing in each one, and if that is true, so that's where we are now passing this in like this. Oh no, sorry, not K, it's J. I was wondering why I was putting the red underline under it, telling me I had something wrong. A couple curly braces. So if we have hit the enemy, what we want to do is we want to make our enemy reset itself and go away and do something else. So to accomplish that, we also are going to need to reset our projectile so that we can use it again. So the first thing that we're going to do is when I hit the enemy, I'm going to make the screen flash so we know it happened. And I can do it by I'm just going to choose blue as my fill color, and then we'll draw it the size of the screen. So if we intersect, we go the size of the screen. And then we can tell our projectile, which is the one that hit, to reset. Now if we had a score, we could be keeping score right now if we still need to destroy the enemy, but again, let's try one thing at a time. So we can see when I'm hitting it, well, when they run into me, it's flashing. Now if I go here, so every time it hits the enemy, we get that little screen flash. So we know that our shooting is working, but we don't have a way to get rid of the enemy yet, so that's what we need to do now, is to figure out how to destroy an enemy. So if I go into my enemy class, update display, I'm going to go right after that. And now this is going to be void destroy. So this is just a new function that I'm making, and we will kill the speed. And then I can set my Vy equal to 0, so it's no longer moving, and I will set my x equal to 0. And by setting it equal to 0, it's just going to bump it over to the side of the screen. So as long as I'm not too close, it won't keep chasing me. So we're going to have to figure out a way to keep our enemies dead. So let's run this again. Move away here. Shoot. All right, we're getting... Oh, we created the method, but we never called it. So enemies j dot destroy. Let's try again. Now it'd help if I hit one. Okay, let's stay over here so I can hit it. So we can see I have 5 enemies, 5 bullets, and they're all over there. Now if I get too close, they start chasing again. But we can put them back in their place. It sounds really bad to say it that way, but that's what we're trying to do, is put them into their place. And now when we do this, so we'll see if I shoot them. Oh, he wants to keep coming at me. But now the other ones, I can't hit more than one because the bullet, my firing timer spaces the bullets out. And if I hit one, it goes and then the bullet resets. So we can see the moment I hit one, the bullet does land back in the reset. It doesn't have to go all the way to the side of the screen. It resets itself. So the bullet's resetting, it's there, but they're not staying dead. And that is what we need to now add to it, is how can we make the enemies stay dead? Well, one thing that we could do with the enemy is we could give the enemy a property of dead. And it's a Boolean because it's either it's alive or it's not. So dead equals false right now. And now when we destroy it, dead can equal true. So we go from dead false to dead true when we hit destroy. We have a couple of options here. One thing that we could do is we could look at this and with the enemy and then make sure that when we hit them, we're only hitting dead ones, but we also want the enemy that if the enemy, we only want the enemy to be coming after us when it's not dead. So back in our main code, if we look at the enemies, we only want the enemies. Now we do want to continue to display the enemies right now in this version of the game, but it could just be if the enemy's dead, we just kick out of here and we don't even do anything with it. But we can say, if actually, so we probably, well, There's a bunch of ways we could do it, but we'll just go for this right now. So if our enemies, as we're cycling through, so if the particular enemy we're working with is not dead, then we want to chase. So if we're not dead, we can chase it. Now it also means that if the player goes where the enemies are stacked on the side of the screen, we are going to see that effect. But now if I go over here, the screen went red, but we can see they're no longer chasing me as part of it. So that's good. But I can still shoot them even though they're dead. So if we don't want that behavior, we can think about where we could put that in the code. So we don't want our projectile to interact with the enemy when they're dead. Well, it would make sense then that's probably going to be inside this loop here where we're checking to see if the projectile has hit an enemy. We only really want to do it when that enemy isn't dead. So then we go enemies j dot dead, but we want to say not dead. And you could do enemies j dot dead is equal to false, meaning they're alive. And if you find dead to be a negative connotation, then you could change dead to alive, and then you'd reverse your true falses. If that makes you a little bit happier, that's fine too. It's all good. It's whatever, makes you happy. Now, if I go here, we can see the projectiles are going right through, and I can even verify that if I go up high here. So let's go above and shoot. We can see it goes right through them without intersecting them. So our projectile is no longer intersecting the enemy. So that's a good thing. If I have a non-square projectile, then it's going to require me to do a little bit of work to reset some things. Now, I could also have 4 separate sprites that I'm working with, and I could be then using those sprites if I had graphics instead of just drawing a simple rectangle or ellipse or circle or whatever you're doing. But let's just say I'm going to continue with this method. And what I want to do is set my width here. I'm going to set it equal to 20, and my height I'm going to set equal to 10. Now the height was 10, but if we start changing height and width as we go through this, then it's going to become important to make sure we're resetting things correctly for each item. So for the up and downs, I want the width to be 10 and the height to be 20. And then, so left and right is set like that. So if we run this, let's see when I fire. Now, notice, once it gets above it, when the bullets or projectiles are landing back in their kind of ready position, they are whatever orientation they were when fired. Now, if that violates your sense of order, that it troubles you, the easiest thing to do would be to set width back equal to 10 and height back equal to 10. So every time it has been fired, it's now going to correct itself to what it needs to be. Now we notice when I run into them, I've made the enemy dead, but it still is affecting me. So that's something I can do where I'm finding out when I intersect the player, and I'm doing this loop here. So now we can do the same thing we did with the projectiles, and we verify that our enemy, K, is not dead. So now when we run it, after we kill them, we can see they no longer affect us after they have passed on to wherever these evil unicorns go. So I managed to be able to fire a rectangular projectile in all four directions. We're moving, we're able to make it so the enemies no longer affect us. Now it could be that you don't want the enemy on screen after it's been taken out, but instead you kick it off screen. But you could put it on screen, but you could have a different graphic. You could have another image. Maybe it's an image of your deceased enemy that you have fired at. So there's options, no matter how you go about this, to keep adding more and more richness to build up a better, more engaging experience. I've modified the enemy a little bit so it doesn't follow in kind of the diagonal twitchy line, but instead it stair steps its way to the player. And the way that I did that is I created a variable and I called it stored time. And it's very much the same way we're using delay to slow down our looped animation so we don't have to have just a bunch of extra duplicate graphics. So when I use stored time, what I'm instead doing with this is I am then inside my chase, I'm only going to update my position. So this is updating our chase direction, which we had before. I've wrapped it in an if statement. And right before that if statement, I'm going to make a query for the current time. Millis returns the time from when the sketch starts running. And then I compare, is new time greater than stored time? So new time started out at 0. Now if new time is greater than stored time, then we are going to update our stored time to be equal to our new time, and then we're going to pass that, or wait, new time is the current time. So new time is the current time, so if the program starts running and 1 millisecond later it gets to this line of code, stored time started out at 0. Then that means we get to run our loop. So stored time now becomes what the current time was. Let's just say 1. We add 500 to it. And then we go and run the rest of the code so it decides what direction to go. The next loop through, which is going to be approximately about maybe 20 to 30 milliseconds later, it's going to check and say, hey, is my new time going to be greater than stored time? Well, stored time, if we started out at 1, we added 500, so it's 501, and we're only 20 milliseconds later, well, that's not true, so we're not going to update our position. And it keeps going until finally new time is bigger than the stored time that was added into it plus 500. So what this does is this effectively means by whatever number I put here, this is how many milliseconds it will delay before it changes direction. So if I wanted it to do what it was doing before, we'll put it down to a 0, so that means there's no change in there, and it immediately, and it gives that twitchy where on the 45 it's go, 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 it keeps alternating position. Now if I were to put this at 1000, so it only will change every second, so now when we're here, it waits a second, and then it goes. Now we'll see it gets this marching pattern on top because it's on top, and it will hold for a second before it changes. I go to 100, we can see those stair steps become much faster. So it's really a matter of what is your artwork, what is your speed of movement, and how does that give you the best result. So 700 is not bad in this case. 500, I think, for this artwork is pretty good. We get a little bit of movement while it's on it, but that's pretty solid. If we go less than that, it starts to become a little, the stair steps start to become really noticeable and annoying. So you're going to have to figure out what number works best for you when you are working on your project. So this one, somewhere between 5 to 700, so I'm going to have it and go 600 and say, yep, that's what I want. So we'll move up here, and that just feels better. Now, if we had a more complex pathfinding algorithm, it would just keep moving only in straight lines, and that's harder code to write, so we're not going to go there right now. So this is a quick fix. It's very much like setting the delay that we did here, which that number changed, but that is going to happen much, much faster. We could use the same method using millis and stored time. We just have a really small number here. That would be a way that we could go about pulling that off. So we could have, two, just grab millis each time and then just two if statements, and we'd have a stored time for movement and a stored time for animation. So we could have two of those, or we can go with the delay as we're using it right now, and then we can see this is happening here. So we look for the stored time. So this, the difference is we took what we had before, and I left it here, just commented out. And this was the Chase code. So this was all that we had inside of Chase. And then I got rid of what was there and wrapped this Chase inside that delay. So now we have a stair step that seems to work. Oh, and in case you're wondering why there's only one, I thought it was easier to show this and what's happening, so I've reduced the number of enemies down to 1. But if I wanted to put it up to 10, now things get a little bit more difficult, especially when I can't shoot diagonally and I can only shoot in the direction that I'm going. Because the other option would be you could set it up that you could have 4 keys for movement and you could have 4 keys for shooting, so you could shoot in any direction while you are running in any direction. And that would be an interesting way of working with the game. So again, lots of possibilities of how to build more to this. Your player could actually be 2 graphics, one for the body and one for the part that is shooting that rotates in any direction that you're planning to shoot. So that would change the graphic. So that would change based on the direction you're shooting, not the direction you are walking. The sky's the limit. It's all about how do you creatively solve the problem. So we're going to be using vectors as a way to keep track of the player so that the player can't go extra fast when they're going diagonal. So the key thing to remember is we're using our vector to store location and to store velocity. So the way to think about that is we can store a location, x and y, and we can store a velocity, x speed and y speed, each into a 2-dimensional vector, so a vector with 2 components on it. So previously we were writing our code out where we would do x is equal to x plus x speed, or plus equals x speed, y is equal to y plus y speed. But what we're really saying is we're taking our location and setting it equal to the current location plus the velocity. So we're just performing the addition of those 2 things every time we update the position of our player on screen. So what we end up doing is we are going to create a new vector, and it's p vector when we're writing it in processing, to store our velocity. And we're not going to make a separate location vector. We could, but we're just going to leave x and y as is right now, because what we want to be able to do is to take our velocity and normalize it. So when we're normalizing the vector, what we're saying is we're scaling it to create a unit vector. So our vector will have a range of 0 to 1, and then we can then multiply it by whatever our maximum speed is. So then when we start moving in what would be a diagonal direction, we're not going to be covering full speed horizontals, full speed verticals, so effectively getting a larger diagonal movement. We want that magnitude of movement to be reduced. So we normalize it and then we scale it. And in this case we used multiply. Some languages we use scale, but in this case we'll use multiply. So we multiply it by our max speed. And then we're able to do our x plus equals v dot x, y plus equals v dot y, when it was plus equals speed x. So the difference when we look at this, I'm going to set the enemies back to 1 so there's less visual confusion going on. And now, if I run this, we'll see horizontal, vertical, diagonal. So we can get a sense of we're moving diagonal. Our magnitude of movement is the same. But if we go back to the old style of doing it, and we just need to comment those, uncomment these, now when I move, we can see that the diagonal movement is significantly faster because each time we're moving a full horizontal and a full vertical. So think of it as we're creating a triangle. So that movement is a triangle. So instead of moving, which I think, here we go, instead of moving all of maximum speed horizontal, maximum speed vertical, we're limiting it. So we say the hypotenuse of the triangle here is the amount we're able to move at full velocity. So we'll move a little less horizontal and a little less vertical as part of it so that it's not so fast when the player is running. So this is a small kind of visual improvement. If you want to avoid the math, just use it as is. If you don't care, use the old one, call it good. You can also set it up with your if-else-ifs on your movements so that each one isn't the same. So you can either do horizontal or vertical movement, not both. That's possible as well. So you would then, every time you're setting a horizontal speed, you kill the vertical. Every time you set a vertical speed, you kill the horizontal. And then that would prevent it. So we can only move in those. And then it's limited by which key you have currently pressed. Again, how you want your project to run will determine what system you choose to use.